ways of how I can give an introduction to this video. The first one being, early on as students, we design buildings through the plan. Then, as we mature, our spatial thinking expands, and we begin designing through a series of vertical and horizontal sections. But this building cannot be designed through the means of 2D projection solving. No. It can only be solved in 3D space. And the second intro being, in all types of ports, be it an airport, a seaport, or a bus station, or a train station, there's always the same way of how they are laid out, how you move through them, how you move in them. It's always this linear motion from point A to point B. Point A being the entrance and point B being the gate or the platform, the ferry, the bus stop, whatever have you. Once you step inside, you're immediately placed on a path without any alternative routes or detours for other activities. You're there to reach the gate and to fly off. Well, this building is different, and it sacrifices directional clarity for freedom of movement. So I kind of like both of these intros, so I'm keeping both of them in. It's my channel, I do what I want, right? But then the question is, what's up with the name of the video, right? Well, I'm glad you asked. So the building that I'm talking about today is Yokohama Port Terminal, which was designed by Foreign Office Architects, FOA, in 1995. I would argue that it's still, to this day, the most beautiful play with urban fabric that we have. The architects have taken the city, stretched it onto the pier, and then cut and folded it into the shape that we have. It's literally the city itself being folded as a kirigami piece. And of course, this is not something that you can just draw. The sheer complexity of the form required extensive use of 3D CAD modeling with some computational design sprinkled right on top of it. Which honestly, it makes sense. If you check the people behind Foreign Office Architects, one of them is Farshid Musavi. I'm butchering that name, I'm sorry if I am. Some of you know Farshid Musavi from two quite popular books, The Function of the Ornament and The Function of Form. Both are really good reads for all of you rhino and grasshopper enthusiasts out there. But either way, we're getting sidetracked. The building is organized into these three levels, vertical levels, that sometimes dip down and sometimes peel up, creating vertical connections in between them. Going through the roof terrace of the building, you can really see how often it bends down, it dips down. Sometimes it makes a terrace or a tunnel that enables you to reach the floor below, right? And I'm not sure if I've ever seen this level of continuity in any other building. It's organic in the best sense of the word. Also, Japan is famous for its angry ground that sometimes likes to shake things up, right? Well, this kind of folding of surfaces makes the building super stable and strong against those kind of forces as well. So it's a win-win situation. Once you step inside, the behavior of the building doesn't really change. When to go down one level, just go where the floor bends downwards. But at the same time, this is where you see the repeat of the origami theme. The top steel sheet cover is folded in a specific origami pattern that gives it great stiffness in one direction, thus eliminating the need for any fancy anchoring systems or even worse, columns. Fun fact, I actually saw the exact same origami pattern used for a steel ceiling under the railway in Tokyo district Shiodome. So I guess this kind of fold-based stiffening became popular. Either way, This weaving of form and spaces that it develops is something that even 30 years later, we don't really see so much. And that is why I feel like this building is definitely worth talking about. I hope you enjoyed this one, and I'll see you in the next one. Later.
の動く段などを預か